Dave Tutorials again. We are here. In this video we are discussing chapter 2, which is sets. So in our last video we discussed chapter 1, which was number bases. So the first category we are discussing is universal sets. So we are discussing universal sets, set complement, intersection of sets, union of sets, more on intersection, and some other word problems. So those are the categories I grouped them into after solving them, so that you will understand it better. So now the first thing we'll discuss are set terminologies. So the first set terminology says a set is a group of well-defined objects or numbers. E.g., the set of integers can be written as z equals. See, this that you see here is a curly bracket. This thing that looks like a arrow, actually it's not an arrow, it's a curly bracket. Okay, it's a curly bracket. So it says a set is a group of well-defined objects or numbers. E.g., the set of integers can be written as that z equals open curly brackets -3, -2, -1, and all that, while the set of numbers on a die is 1, 2, 3, 4, 5, 6. So now that is a set. You must always take note that whenever you have different things, just like when you place a bag and a book in a safe, you can call them a set because they are both in the safe. It's not just a single thing. So a set is a group of things. You can say a set of books, a set of bags, a set of biros, a set of stationaries, a set of equipment, So that's the set. So the next terminology is member of a set. So it says any member of a set is referred to as an element of the set. E.g., 3 is an element of the set D, written as 3 subset D. Take note, this sign is a general sign representation of member of a set. Let me show that here. So this is the sign. Whenever you see this sign, always take note, this is member of a set, this is subset. Whenever you see this, always know that it's subset, and whenever you see this, always know that this is member of a set. They are different, but sometimes they look alike, but they are actually different. So you will meet them as we go on in the lesson. So it says the next, okay, said 3 is a subset of D. On the other hand, 8 is not an element of D. That is, 8 is not an element of D. So now this means not an element, this means it is an element. So this means not, oh sorry, that's a mistake. This means that is an element. So this means it is not a subset, this means it is a subset, but mostly they don't write this not a subset mostly. So but I just want you to understand that before we continue. So now, so they said, so 8 is not a subset of D. So, and the next one says an infinite set is one which contains an infinite number of elements. E.g., set Z above. This set Z we have here, set Z. Okay, he said while a finite set contains a definite number of elements, e.g., set D above. This is set D. That means that set D is a finite verb. So this is telling us that an infinite set is one which has infinite number of elements, which means it is never ending. So, and one thing we need to take note of is whenever we are expressing, this is the curly bracket that I spoke of, whenever we are expressing an infinite set, you must always take note that let's take for instance, if the materials we have in the set are 1, 2, 3, an infinite set always ends in ... That's the representation that it just continues, it doesn't have an end. So that's the representation of that. So that is an infinite set. So the next one says an infinite set is one which contains an... I had said that already. So the next one is if every element of a set A is also an element of a set B, then A is a subset of B. Now see what I said before. This is the sign that I spoke of. Sorry, let me adjust that a bit. This is the sign. This is the sign. So as I had said before, that is the sign I spoke of. So, and that is sign of subset. That is sign of subset. So, and now said, e.g., D is a subset of Z in the example above. So, and that is it. So D is a subset of Z. So let's move to the next one. It says now an empty set or a null set. An empty set or a null set written as this. Okay, I'll write that out now. So whenever you see this or this, it always represents an empty set. So it doesn't represent any other thing apart from an empty set. Whenever you see it in a question, always know straight away that this is an empty set. It means there is no element in the set. So it's also called a null set. So now that we have explained that, so that is an empty set. So e.g., the set of integers between 1 and 4 which are divisible by 5 is an empty set. So there is no element that is divisible by 5 between 1 and 4, and that is why the elements is an empty set. So now the next terminology is universal set. So this is a universal set. A universal set is defined as the set of all elements under consideration. So let's take for instance, I can have a set. Let's take this as my universal set. Universal set is represented as capital letter U, or it's always represented by this also. It can also be represented by this. So those are the three representations of a universal set. But at times, most of the times, it's always represented with this. Most of the times you always see a universal or with that or this, most of the times. So now let's take for instance, if we have a universal set to be 1, 2, 3, 4, 5. So we have our universal set to be that. So and now we now said A equals 1, 2 and B equals 3. Let me write that again. Equals 2, 3, 4. So they now said identify. They now said identify in the set if B is a null set or an empty set relative to the universal set. So if they ask this kind of question, it actually means that you are going to look at B, look at the elements inside of B. If it rhymes with what is in the universal set, then it is not an empty set. But if it does not rhyme, then it is an empty set relative to the question that was asked. So but normally if we look at it, B contains the elements of the union set, of the universal set, so it is not an empty set. But if the question they asked was that you should check if B contains the element of the universal set. If it doesn't contain it, like if it's let me adjust that. If it contains elements like, okay, if it contains elements like A, B, maybe it contains A, B now, and they ask that kind of question that we should check if B contains the elements of B can be referred to the universal set, because the universal set is the overall set, so it should contain all the elements. So if it doesn't contain it, that means B is an empty set. It's just a lie of a set. It is not really a set, it is an empty set. So now that I've explained that, okay, just give me a minute here. So now I'll move on to discuss on the segments I broke the sets into. So based on the topics now, so the first says universal sets. So now I'm moving into universal set questions. So this is a question on universal sets. It says if U equals, let me put that very well. It says if U equals 0 to 3, 6, 7, 8, 9, 10 is the universal set, E equals 0, 4, 6, 8, 10, and F equals x squared, it's just an expression, equals x squared equals 2 raised to the power 6, and x is odd. So that tells us that for everything that can be contained in F, it will be based on that equation that was written inside of it. And it tells us that to get that equation, everything of x must always be odd. So if x is not odd, that means that we have not gotten the correct thing for that element. So let's first of all write the universal set out. That is the first thing to do whenever you are solving any set question and you have universal sets. What you are advised to do is to first write out the universal set. Let me first read a line here. Okay, after doing that, so let me write the universal set out. Universal set equals, opening our curly brackets, 0, adjust this a bit, 0 to 3, 6, 7, 8, 9, 10. So that is our universal set. So now the set E equals 0, 4, 6, 8, 10. So that is for the set E. So then I said for the set F, we don't know the true values of that yet. So but for the set F, we have our equation, which is x squared equals 2 raised to the power 6. So now to solve this and get our value, but they had already said that x is odd. So if we are solving it and we don't get odd values, let me rewrite that. The handwriting is not so good. Okay, so if we are solving it and we don't get odd values for x, that means that we are wrong for the elements of F. So now what we have to do now, so according to our law of indices, so we can just simplify it through and get that x equals 2 raised to the power 3. according to our law of indices, we can just cancel the raised to power 2 out, so, and we get x equals 2 raised to power 3. So now getting this value now tells us that our x can never be an odd value. So, and in this kind of a situation, it tells us that we can never get the value of x. So that means that our f is an empty set. It is an empty set. So now, having that done, they now said find E intersect F. I had not explained intersection of sets before, but intersection of sets is a process whereby whenever you have a set, I just want to come to a side here to explain that well. Okay, so whenever you have a set, let's take for instance, maybe the first set is A. Okay, the first set is A, and A equals 1, 2, 3. The second set is B, and B equals 2, 4. So now the intersection of sets in these two is equal to 2. The reason for this is because intersection of set is a process whereby you look at what is common in the two sets, and when you look at the two in these two examples, you get 2 as your value. So that means intersection of set for these two is 2. With that being said, so now if we now look at the intersection of set for E and F now, it tells us that there is nothing common in both, because E is not an empty set, so there is nothing common. So whenever you check two sets and you don't see anything common, and they said find what is common there, what you must always give as your answer is always empty set, because it is an empty set. There is nothing there, so it's an empty set. So that tells us that our answer is D. Many will make the mistake and choose 0, but your answer is not 0, because 0 is not even in the set. So now, so this is the representation of a universal set in a diagram. A universal set is mostly always written at one side here. So a universal set is always the summation of everything in the diagram. So, and that is always the universal set. So it's always written at one bottom here, and that is always the universal set. So now the next thing we are to discuss now is set complements. Okay, so now I just want to use this diagram to explain it before I solve questions. So now let's take, for instance, let's take this as A, and let's take this as B, and let's take this as C. Okay, let me take it to be just 2 sets, not 3. Okay, so now let me take this as A, and take this as A, take this as B. So now if we are to deal with set complements, set complement is a situation whereby whenever we choose A, whatever will be left apart from A, totally apart from A, is always the complement. So now in this kind of a question, now if we are asked to get the set complement of A, the set complement of A is everything that will not be shaded when A has been shaded, and everything that will not be shaded when A has been shaded is not